Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Building a Simple RL Agent, Making AI Learn to Play a Game. Imagine an AI that learns like a child, by trying things, making mistakes, and figuring out what works best. That's reinforcement learning. RL. Instead of us giving it a giant rulebook, we let our AI play a game repeatedly, and it slowly discovers its own winning strategy. Think of it like teaching a pet tricks with treats and encouragement, rather than writing a detailed instruction manual for it. In RL, we have two main characters constantly interacting. Asterisk the agent, your AI player. This is the brawn you're building. It's the decision maker that chooses what move to make in the game. Asterisk the environment, the game itself. This is the world where the agent plays. It shows the agent what's currently happening, changes based on the agent's moves, and gives feedback. Think of a chess player. Agent, sitting at a chessboard. Environment, the player makes a move, the board changes, and the player reacts to the new board state. To communicate and learn effectively, our agent and environment use three key concepts. State, asterisk what the game looks like right now. For a simple maze game, this might be I'm at position X, Y, single quote. For a developer, this is typically represented as data, numbers, arrays, or objects describing the game's current condition. Action, asterisk a specific move the agent can make. Examples: move left, jump, place an X on the board. From a developer's perspective, these are functions or commands the agent can trigger. Reward, the feedback, a number the agent gets after taking an action. A positive number means good move, e.g., scoring a point. A negative number means bad move, e.g., losing a life. This score is what guides the AI's learning. Here's where the magic happens. The agent plays the game over and over again, in a continuous loop. 1. The agent observes the current asterisk state asterisk of the game. 2. It decides to take an asterisk action. 3. The environment reacts to the action, gives a asterisk reward, or penalty, and updates to a new asterisk state. 4. The agent remembers if that action, taken from that specific state, led to a good or bad reward. It's like trying different routes to work. If one route is faster, positive reward, you'll likely try it again. If it's slower, negative reward, you'll avoid it. Your AI builds a mental map of good and bad moves. How does the AI remember what's good or bad? We can use a simple data structure called a Q table. Asterisk imagine a giant spreadsheet, or a 2D array in programming terms, where each row represents a possible state and each column represents a possible action. Asterisk each cell in this table holds a Q value, which is the AI's current estimate of how good it is to take that specific action from that specific state, considering not just the immediate reward but also future rewards. Asterisk initially, all values are 0. As the AI plays and gets rewards, it updates these values, gradually filling out its cheat sheet for optimal play. For you, the developer, implementing this involves representing states, asterisk often as unique integers, strings, or tuples, e.g., backquote, x, y, backquote for a position, defining actions, asterisk usually as simple integer IDs, e.g., backquote 0 backquote for up, backquote 1 backquote for down. Creating the Q table. This will often be a Python dictionary mapping backquote, state, action, backquote pairs to Q values, or a NumPy array if your states and actions are easily indexed. Writing the learning loop. Asterisk a backquote while backquote loop or backquote for backquote loop that runs for many episodes. Game plays. Implementing the update rule. Asterisk a bit of math that adjusts the Q value in the table based on the reward received and the estimated future rewards. This is the core of how the AI learns. Let's use a classic example. Frozen lake. Your agent starts on a slippery frozen lake and needs to reach a goal. Avoiding holes along the way. States. Asterisk each square on the lake grid. E.g. Start. Ice 1. Hole. Goal. Actions. Asterisk move up, down, left, or right. Though due to slipperiness, the agent might move in a different direction. Rewards. +1 for reaching the goal. -1 for falling in a hole. 0 for moving on safe ice. Asterisk initially, the AI will stumble randomly, often falling into holes, but over thousands of episodes, tries, it will learn which actions from which states consistently lead to the +1 reward. Finding the optimal, safest path to the goal by updating its Q table. This simple Q learning approach is perfect for understanding the basics and works well for small games with a limited number of states and actions. However, for much larger, more complex games, like chess or Go, or even controlling robots, more advanced techniques like deep reinforcement learning, which combines RL with powerful neural networks, are used. But the core ideas you've learned today, agent, environment, states, actions, and rewards, remain fundamental to all of them. You now have the basic building blocks to understand much more complex AI systems. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.